afternoon. We are comments for our Magnet Navigation. Our team members are Shane, Ned, and myself, Edson. As of now, I would like to ask for just a moment if you could just please close your eyes and imagine if you couldn't see. Think of all of the things that you will be missing on. To address this, our team is developing a wearable device that will allow the visual aid and the impaired to be able to experience more of the visual world. As well, it will have a unique design that will allow to be appropriate for any environment, complementing other products in order for navigating on foot.
So, our device recognizes nearby objects and it informs the user via audio tones and according to their position and importance. From a high-level perspective, the onboard camera captures a new image and therefore informs the user about its position. And this is through the use of saliency and serve key point matching. When an object is classified as important, the device will play an urgent tone, otherwise a softer tone.
For starting out, we're going with 5 different signs: stop, crosswalk, cross here, don't cross here, and railroad crossing, since they're most relevant to pedestrians. And at the same time as the image detection is going on, that my colleague mentioned, we'll be using the sonar sensor on the side to detect if any obstacles approaching and warning the user. As well as on the other side, we'll have inertial measurement unit, which will detect head movement for hands-free control with gestures. Looking up will change the amount of detail the device provides. While tilting your head will request more information.
So one might ask, what impact will this device have? Our goal is, according to the American Printing House for the Blind, blindness among children is around 62,000 in a 2016 report, and 7.3 million among adults in 2015. Our project aims to help this demographic in order to further their independence in an unobtrusive way.
As you can see on the bottom there, our quick guideline is we'll begin ordering parts from August to September. Then from September to October, we'll do the hardware, training the machine vision, as well as system level development, all in parallel since we can split it up. Then from October to November, we'll do our final reports, and in December, give our final presentation. Thank you for your time, and would now like to open the floor to questions.
What is comments for augmented navigation?
That is our team name.
Okay.
Comments being the school mascot.
Sure.
Yeah.
Why do you need a camera if the person can't see?
Pretty much it's going to be the object recognition. As Shane mentioned before, we're using 5 signs, and those 5 signs are going to be, we're trying to do machine learning, and we're trying to keep it something that will be reachable within the months that we have. So the camera is going to recognize the image, and it's going to be processed.
So it's a sensor only, basically.
Right.
Okay.
So this is actually a camera, and we plan to use something already made that's called Chipwa, and that device is already trained for a user to program it, and we can create our own database of the images that we want to recognize. In this case, we do want to focus on pedestrian signs.
So depending on the sensors that you have, and maybe you already figured out how you're going to bring all those sensors together and develop it into an algorithm, right? So do you know what you would need on that single board computer chip?
With the single board computer, our main focus is just integrating all the information together, because the camera also has an integrated GPU and all that for image processing. The single board computer will take in the peripherals like the sonar, the head tracking. It'll do some processing to figure out how to place the audio cues left to right, and then send it to the speaker. So ideally it won't do much, just tie everything together.
So would it be a microcontroller? Would it be a DSP? Would it be like an ARM?
Probably Raspberry Pi.
Okay.
We're still looking at options.
What do you use? What? Oh, go ahead. What are you using for speakers? Is there something clipped on the earpiece there? Is that what that is?
Yeah, well, we're using bone conduction speakers.
Oh, okay,
So
okay.
that way they can still use their normal hearing, and then we add on top of that.
Your bone conduction. Okay.
Yeah.
Have you considered the potential ethical issues associated with somebody walking around with a camera all the time that doesn't even know what they're looking at? Might be in a situation where it would be inappropriate.
We're hoping with this that it will only be used in situations where it's appropriate, like public environments, walking along the street or whatnot,
Mhm.
where you already have traffic cameras and other devices. And we
Okay.
won't be saving any images, only detecting, giving the feedback, and then discarding.
Size.
Second's the right answer.
All right, let's thank the team.
Good job.